Learners, welcome to our telematics session this afternoon, where we will be looking at geography map work. Now, you have been preparing for your grade 12 map work exam since grade 8 already. We've been learning the various map work skills, the techniques that we need to use, and from grade 8 we've been building onto that, and you are now on that fourth rung of the ladder, the grade 11 rung, which is the last one before you get to your grade 12 final mapwork exam. The slide that you see in front of you shows a few of the concepts and skills that you need to master in order to pass that grade 12 mapwork exam. Before I go any further, let me introduce myself. I am Mr. Regan Ford from Belgravia High School in Athlone, and I would like at this stage to thank Mr. Glenn Samai for the PowerPoint presentation that he has prepared for us this afternoon. Let's get kicking. Map skills. You need to know how to do direction and bearing. I will go through that with you this afternoon. You need to know how to interpret the map symbols. I will show you later on. It's not necessary to remember them all, but we need to know what they are so that we can interpret them and that we can use these symbols to tell us more about the map that we are looking at. The third thing, the reference of the map. I will be doing map reference with you, how the map gets its name, and what we need to know there. We will then move on to coordinates. Lots of learners struggle with coordinates. It's actually quite simple, and we will definitely be spending quite a bit of time looking at coordinates and how to determine the position of a place using the coordinates. We will then move on to contours, the various aspects with contours, how to tell if a slope is steep or gradual, the type of slope, etc. Also relating to contours, we will look at trigonometrical stations, spot heights, and benchmarks as indicators of height. And we will also be looking at the direction of flow of a river, how to determine in which direction a river is flowing. Right, let's start with the map symbols. Now, as I've mentioned earlier, when it comes to the map symbols, these symbols tell us what is happening on the map. A map is a representation of reality. It is not reality itself. So you're not going to see a road or a railway line or farmlands or a building on the map. We use symbols to show us these various aspects, these phenomena which occur on a map. Now, at the bottom of the map, you will have a key showing you the main symbols on that particular map. So in this case, you can see the first 1, 2, 3, 4 symbols, 5 symbols indicate the various types of roads on the map. And something that you must just take note of, if you look at the first one, the National Freeway, semicolon, National Route. This means that the N over here shows me that it is a national route or national freeway, a highway, as we sometimes call it. The blue line is first, National Freeway, goes with the blue line. So if you see a blue line with that N symbol, it is a national freeway. If you see the red line, it is a national route. What's the difference? A national freeway means that traffic can flow freely, as the name would suggest. But you know that sometimes when you're driving along a freeway, you get to a small town and the national road has to pass through the town. Now you can imagine we cannot be driving at 120 kilometers per hour through a little town like, say, for example, Napier. So the traffic has to slow down. And at that point, your freeway becomes a normal road, which we just call a national route because it's part of the route. We get the arterial route, main road, etc. I'm not going to go through all the different types of roads, but those are all my road symbols, then my railway lines, etc., etc., etc. As I said, you do not have to remember, any of these. The ones that you use more often you will remember out of repetitive use, but the symbols will be indicated on every single map that you get. What is more important, that you understand what these symbols are. Ask your teacher. If you do not know what a trigonometrical station is, ask your teacher to show you a picture. Use your Google search facility. Look for it. See what it looks like so that when you see the little triangle showing you a trigonometrical station, you know exactly what it is and what it is used for. And the same goes for all the others as well. Just another little thing, in the matric final exam, for example, if you take on this screen, the fourth one from the bottom, the cultivated land, you are often asked, what is the land use? Now, cultivated land is not the land use. That symbol shows me that the land is cultivated. What is the land being used for? It is being used for agriculture. So those are the sorts of things that you need to make sure that you know. Orchards and vineyards below that, the land use is not orchards and vineyards. Orchards and vineyards are being grown, but the land is being used for fruit farming. Okay? So you need to ensure that you understand. It's very important that you understand the symbols and that you can then use those symbols to interpret what is happening on the map. Right. Our symbols, we can divide broadly into three groups. Point symbols, buildings, the first two indicate buildings, larger buildings, smaller buildings, right? A church, a kerk, in Afrikaans, a place of worship, a school, etc. That's a wind pump, the trig beacon that I spoke about, a lighthouse, or point symbols. Then we get line symbols. The line symbols will be our roads, national roads, etc., railway lines, power lines, rivers. Any symbol that is linear in shape would be a line symbol. A contour line could also be included here. Then we get our area symbols in the GIS section, which you will be revising later. We speak about polygons, and our area symbols would also bodies of water, cultivated lands, diggings, excavations, cemeteries, marshes, permanent water masses, etc. Okay? So those are symbols that are area symbols. We could also include things like a golf course or a lake, etc. That takes up an entire area. So we have point symbols, line symbols, and area symbols. And these correlate closely with the points, lines, and polygons that we speak about in our GIS section, which I said you will be revising at a later stage. Right. How are the following photos represented on topographic maps? So I will give you a photograph, and there are three symbols, and I will check the WhatsApp line now. So there are three symbols. There's a photograph. What do you see in the photograph? I see a road. The road is crossing a river. What is the structure called where the road crosses the river? It's a bridge. So of the three, which do you think is the correct answer? A, B, or C? I'm not getting anything on the WhatsApp line yet. A, there somebody said A, 7473159194, and all the answers. Valhalla says A. I'm assuming that's Valhalla High and the Cape Flats. Welcome. Right, answer A is correct. That's the symbol for a bridge, right? B would be a railway line with a station. The black line is the railway line, and the little white block represents the station. That's a road, and that symbol is a bridge. And this symbol at C, we all know, is a power line. So the answer is A. Okay, you can stop sending through the answers for that one. Let's look at another one. What do we have here? We've got, looks like a farm to me. There's rows of maize being grown. So this is some sort of cultivation. What is the answer now? A, B, or C? And I'm waiting for answers to come through. The first answer says C, then a B, then a B. Hans by Academia says B. And most of you are saying B. I've got two C's and a whole lot of B's. The correct answer, in fact, is B. Why is it not C? Remember, I told you that it is maize being grown here, and that is a crop. B is cultivated lands. C would have been orchards or vineyards, so C would have been fruit farming. So if there were rows of apple trees or oranges or pears or grapes or whatever, then C would have been the correct answer. But it is B, cultivated lands. Well done. The last one. There is a little structure on top of a brick tower. What do you see there? Does anybody know before I tell you what it is? I've got an A, got another A. Right, Valhalla High once again says A. Got quite a few A's, and A is correct. The structure that you see is what we call a trigonometrical beacon or a trigonometrical station. It's a concrete base, and it has a metal plaque at the top, which shows us how high this point is above sea level. This you would normally find on a mountain peak, up on the hills. Here it is situated on a concrete little tower, probably on top of a dam wall or something, to show how high we are at that particular point. So it is your trig beacon, C. Well done for all the answers. Yes, A is the wind pump. Someone is saying that A is the symbol for a wind pump. And B, can somebody tell me what B is? That's absolutely correct. B is the symbol for A. Anybody else? It is a lighthouse. Absolutely correct. Right. Direction and bearing. Everybody's nemesis. Now, direction and bearing are very, very closely related. Now, before I go on to my PowerPoint, I'm going to show you something very, very easy that should make your life much easier. So on my sheet of paper in front of me, I'm just going to draw a line, and my drawing is going to be very, very rough, but that's not a problem, and I'm going to draw another line. So on a map, we know that direction is always north, this direction is south, that's west, and that's east. Right. Now, if I use my protractor, and I put my protractor down there, I can see that the angle I'm starting to measure from 0. I don't do this. I want to measure the angle from north to east. If I do this, and I often see learners doing this in the exam, I'm starting to measure at 90. And none of you starts counting at 90, do you? No, we turn it around, put my protractor, then I can see that from north to east, even in my rough drawing I was correct, the angle between north and east is 90 degrees. The angle between north and south is 180 degrees. I don't need the protractor for this, do I? North, 9, 18, then this must be 27, 270 degrees. Now, if I draw in my other angles, I now have northeast, southeast, southwest, and northwest. And now we can give them a value too, because if north is 0 degrees, then that is halfway between 0 and 90, so that will be 45 degrees. 90 plus 45 is going to give me 135 degrees. 180 plus 45 is going to give me 225 degrees. And then 270 plus 45 is going to give me 315 degrees. Now, what is important is that the angles in between, or the directions in between, anything in the space here, we work very roughly, is between north and northeast. And here learners often get confused when naming it. It's between north and northeast. I first write down the single letter, then the double letter. This direction in between here is between northeast and east. I don't say northeast, east. First the single, then the double. East, northeast. Anything in there is between east and southeast. First the single, then the double. You getting it? Southeast and south. South, southeast. South, southwest. Easy, isn't it? West, southwest, west, northwest, and northwest. Now, this is very basic, but if you understand the basics, you will understand everything else. Now, when you are measuring the direction and the bearing between 2 points, what you are actually doing, the point that you are measuring from is the center of this diagram. But you don't have to draw this entire diagram every time. All that you have to draw is the line going north and then the line joining the one place to the other place. So you're only going to draw 2 lines. For example, that one and that one, or that one and that one. And then we're going to measure the angle. Okay? So let me just move this and I'll give you an easy example. All right. So let's say I have a place here. Let's call this place A and let's call that place B. And I have to measure the direction and bearing from A to B. What do? A is my starting point. I ensure that I get a straight line from A in a northerly direction. Now it's important that this line is very straight because I'm going to measure from, if this line is skew in that direction, my angle is going to be too big. If this line is skew in that direction, my angle is going to be too small. So it has to be straight. I'm lucky that I've got a nice square area in which I'm working so I can get my line straight. Then I will join the 2. Oopsie, doesn't matter, my first part was straight. Join A and B. Where's B? And now I use my protractor, center point of my protractor on the center point, the baseline of my protractor on the baseline, and I measure and I get 66 degrees. So that's my bearing, 66 degrees. Then I come back to the sheet. Where would 66 degrees fit in? If that's 45 and that's 90, 66 degrees is going to be somewhere in this area here. Do you agree with me? Between 45 degrees and 90 degrees, 66 degrees would be somewhere in this area here. So it would be east, north, east. You get it? If your angle is bigger than 180 degrees, if your angle is bigger than 180 degrees, I've got to calculate once again from A to B. From A to B. What are the steps? Line north, line joining the 2. I have to measure from north in a clockwise direction. But my protractor can only go up to 180 degrees. If you have one of those fancy 360-degree protractors, that's fine. But this one will work. So what are we going to do now? This here is the angle that I don't want. Do you agree with me? I don't want that angle. I want this one here. But I do know that a complete circle is 360 degrees. So if I measure the angle that I don't want, same process, center point, I'm using the inside scale of my protractor because I start counting at 0. 10, 20, 30, that's 110. Just short of 120. Let's make it 120 degrees. Now, I will say 360 degrees is the entire circle. The section of the circle I don't want is 120 degrees, and that will give me 240 degrees. And then I come back to my little sketch. You can just draw this in your exam on the back of your question paper somewhere, roughly. And 240 degrees will be somewhere between 225 and 270 in this area here. So it is west, south, west. Right, let's go back to our slide presentation. And we can see, here's an example. In a Mapwork paper, determine the direction and bearing from the farmhouse. The farmhouse has the little red circle. That symbol there is the symbol for a farmhouse. There we can see cultivated lands once again. That reinforces that farming is taking place here. But we went from the farmhouse, so that's going to be our starting point, to trig station 210. And while we are here, remember you will always 2 numbers associated with a trig station. 210, 135.0. The number with the decimal place is always the height, the altitude. This is how high it is above sea level. This is trig beacon number 210. You can't have trig beacon number 135,6, for example, because each trig beacon has a number. There's number 1, there's number 2, there's number 3, etc. Right? So this is trig beacon or trig station number 210, and its height is 135.0 meters above sea level. Right. Let's see the steps. Draw a north line from the farmhouse. Did that? And then we draw a line from the farmhouse to the trig beacon, because the question says determine the direction and bearing from the farmhouse. So that's where our north line goes to the trig station. Okay? And now you know we've got to measure that angle in a clockwise direction. There's my protractor. We measure the angle and we get 149 degrees, and that should give us a south-southeast direction. Okay, here Mr. Samai has just given a rough direction southeast, but we know that accurately, what was that angle now? Sorry, 149 degrees is between 135 and 180, so it is more south-southeast. Another example, the wind pump in block D3 and the spot height in block C5. There's the wind pump. We've joined the two. North line from the wind pump. Measure the angle. 54 degrees. And 54 degrees is between east and northeast. In fact, it's very, very close to northeast. So it is somewhere between northeast and east-northeast. Right, I think you have the hang of that now. Right, let's move away from this. If you are still struggling with the section, please take time to practice. Ask your teacher to give you examples. Ask your teacher to sit with you and to go through it with you again. And before you know it, you will be able to calculate bearing very, very easily. One last thing I want to do with you before I move on to the next section. If you look at the bottom of your map, take, for example, the Maatjiesfontein map. If you look at the bottom of your map, you will see an indication of what the mean magnetic declination is. Now, you know that the mean magnetic declination is the angle between true north and magnetic north, right? Your teachers explained to you what true north is, what magnetic north is. That's the angle between true north and magnetic north. And in the case of this map, it is 24 degrees, 30 minutes west of true north. So in other words, if that is true north there, then magnetic north, that angle is 24 degrees and 30 minutes west, right? That direction is west of true north. Now, when you get asked to calculate the magnetic bearing, it's very simple. You calculate your bearing as normal. So in the first example that I did, I got a bearing of 66 degrees. Then all you do is you add that, the magnetic declination. So 66 degrees plus 24 degrees and 30 minutes, that can be written as 66 degrees 0 minutes, will give me 30 minutes. That will give me 10, 8, 90 degrees and 30 minutes would be my magnetic bearing. So in order to calculate the magnetic bearing, you do a normal measure of bearing and then you just add the magnetic declination to that bearing so that you have your magnetic bearing. MB, your magnetic bearing. All right, let's move away from this now. And we are now going to have a look at contours and slopes. Now, this is something that you've been doing since grade 8. I teach a grade 8 class at my school. And in the first term, this was one of the things I did with my grade 8s. So, let's have a look at the slope here. What do we see? 50 meters, 100 meters, 150 meters. What do we call what do we call the gap between the contour lines? Can anyone tell me what's the term that we use for the gap between the contour lines? You can send me answers via the WhatsApp line. Nothing yet? Okay, I'll put, there we go, contour interval, 064781, that number. Contour interval, that's correct. So the contour interval in this case is 50 meters, 50, 100, 150. And what do I notice? As I move from A to B up the slope, can you see here how far the contour lines are from one another? And the further the contour lines are, the more gradual or gentle the slope is. And look at here, the slope here going from 50 to 100 relatively gently. And what is happening here? I can see over here the slope is increasing steeply. Let's go and look at the contour map. Can you see the corresponding contour lines are close to one another? The corresponding contour lines are very, very close to one another, and that indicates a steep slope. So when we have in the lower parts of the slope further contour lines, gradual slope, and then becoming steep in the upper part of the slope, we have what we call a concave slope. The opposite of that obviously is a convex slope. Notice here, 100 on this side, 800 on that side, so my altitude is increasing that way. So if I start at the bottom of the slope at A, I first have a steep slope, and then it becomes gentle. My contour lines are close together first, and then they become spread wider apart. So it's first a steep slope, then a gentle slope. And if you look at the cross section at the bottom, first a steep slope, then a gentle slope. So this slope is convex. Your convex is the opposite of your concave. And in the third slope is what we call a terraced or stepped slope. Here we have far apart, close together. Far apart, close together. We have a pattern. Far apart, close together. So what's happening? Wherever the contour lines are close together, the slope is steep. Right? There the contour lines are close together, there the slope is steep. Then the contour lines are further apart, then the slope is gradual. Steep, gradual. So that gives us this effect of steps. Gradual, steep up the step. Gradual step, steep up to the next level. Up to the next level. And usually with the terrace, farming will be taking place on the level parts. Right. Here's a question for you. This extract is from the orthophoto map of Maatjiesfontein. Oh, I pick up a spelling mistake, the orthophoto map of Maatjiesfontein. Let's look at these two slopes. To the right, we've got slope A. To the left, we have slope B. Very simple question. Which slope is steeper? And give a reason for your answer. I have from telephone number 0718394592 says A. Are there any further answers? I also need a reason for your answer. A, another A. Okay, 3 people so far have told me A, 4 people, but I'm still not getting a reason. Why? Can somebody give me a reason? A is the correct answer. Absolutely correct. 0724677768 says the contour lines are closer together, and everybody else, including Hans by Academia, is saying A because the contour lines are closer together. Well done. So we can see the contour lines close together. That slope is much steeper, and in that slope there would be more gradual because the contour lines are further apart. Steep contours close together. Gradual contours are further apart. They are closely packed. That's another way of putting it. Well done. Okay, we can stop answering that question now. Let's move on. How do we represent height? Now, we said earlier that on a map, it's a representation of reality. It's not reality. Now, if I'm standing outside, I can see there's the top of the mountain, here's a river at the bottom, etc. I can see the height of various places or various points on my map. But on a flat map, how do I indicate which parts are higher and which parts are lower? And that's important because we're going to be using a map when we want to go hiking, if we want to travel, and we often want to work out what's going to be the easiest route to take. So, if you look at the slide, the slide looks very, very busy. There's a lot of things on it, but let's zoom in on a few things. The first thing I want you to take notice of are the contour lines. Now, you know that those brown lines on the map are contour lines. And if you look closely, some of them have numbers written on them. Now, we know that the contour interval, whom of you can tell me what's the contour interval on a topographic map? Very, very quickly. I just want 1 or 2 answers to come through because we're going to run out of time soon. Absolutely correct. The contour interval on a topographic map is usually 20 meters. So every single contour line does not have to have the height indicated on it. As long as a few of them have the height, we can work out 20, 20, 20 each contour line. So contour lines are one way of showing height. And why I like contour lines? Because they also show me the shape of the land, but we'll get to that now. There, that one is 760 meters. That one is 720. Then our trigonometrical stations, or trig beacons that we looked at earlier. Once again, remember I said there are 2 numbers. Trig beacon number 72 with an altitude of 877,9. Remember, it can't be trig beacon number 877,9. Trig beacon number 72, and that is the height. Please don't get confused. Spot heights. 853, 855, 681. Little dots with a number next to us showing us the height. And then lastly, benchmarks, which are usually alongside a road, 733.2, 719.7. Now, people, of those four elements there, 2 of them exist in reality, being the trig station, you saw a picture of one earlier, and the benchmarks, right? It's usually like a little concrete slab along the side of the road showing us the height. The other 2, the spot height and the contour lines do not exist in reality. There are no lines painted on the Earth's surface. There are no dots on the Earth's surface with numbers written next to them. That is just for us to interpret the map, to show us what the altitude is at various points on the map. Right. Here's a block from a map, from the Maikisfontein map. And the question in the exam is, give 2 ways in which height is represented in this red block on the map. Right, I'll wait for you to respond. Look at this red block and give me 2 ways. What are the 2 easiest ways? Along a spot height, well done. That comes from 0659738749. A spot height, there's a spot height 1016. We can all see that one. And there are contour lines on the map. That answer comes from 07246776768. That number is answering a lot, and everybody else is a flood of answers now, all absolutely correct. Right. Contours and spot heights. There's lots of contour lines, and there are 2 spot heights in the block as well. Right, let's move on. Map reference. Many of you have a problem with this as well. Now, I'm going to use my slide, but before I go there, let me just very, very quickly do it for you on a sheet of paper. I'm going to do it very, very roughly. I'm not going to bother to use the ruler. If I have a line of latitude and a line of latitude, let's give this line a value of 33 degrees, 0 minutes, and let's give this one 34 degrees, 0 minutes, right? So that is 1 degree of latitude. And then let's take another 2 lines. There's one, and there's one. And let's call this 17 degrees, 0 minutes, and 18 degrees, 0 minutes. Now, this area is a very, very large area. So what we do, we divide it in half this way. And you know that there are 60 minutes in a degree. So this line will have a value of 33 degrees. And because it's halfway between 0 and 60, 30 minutes. And that line there will have a value of 17 degrees and 30 minutes because it's halfway between 17.0 and 18. Now, this block, we are going to call block A. I don't want to write in it yet. That's block A, remember? A, B, C, D. Can you remember that? A, B, C, D. Now, each of these blocks I further subdivide. So So this one will be 15 minutes. And this one will be 45 minutes. Okay? And then further subdivide this. This will be 17, 15, and 17, 45. Now, can you remember this block was block A, so I'll just put an A there in each of these. This block was B. So each of the sub-blocks will start with a B, because that was big block B. This was big block C, so all the small blocks in that is going to start with a C, and then D. Okay? Now, once again, the small blocks get the letters well A, B, C, D. Notice the direction in which I'm moving. A, B, C, D. A, B, C, D, and then here A, B, C, D. So this, for example, is small block A within big block D. Small block C within big block B. Small block B within big block A. You get it? Each one of these is a topographical map. Now, how are we going to give the title of this map? Let's take one at random. Let's take this one here. Let's take that block there. What will the title of that map be? Can you see that for each of these maps, the first line of latitude is 33 and it continues. 34 will be the maps below that. So, the title of that map is going to be 33, because it's the first line of latitude, and you guessed it, 17 DA, and then the name of the biggest town on the map, Mapwork or Paul or whatever the case might be. Okay? This one here is going to be 33, 17, AC. Every single map here is going to start with 33, 17 in this series of 16 maps. Okay? And that is where the map gets its name from. Let's go back to our slide quickly. And you can see exactly what I said. There's big block A, B, C, D, smaller blocks A, B, C, D within each big block. Mapwork is 3320. So Mapwork will have a latitudinal position of 33 degrees and a longitudinal position of 20 degrees, and it is in block BA. Where's block BA? 3320 BA. That's the latitude. Okay, the 20 is the longitude. And BA is that block. Big block B, small block A. Okay, everybody happy with that? The question, give the map reference of the map west of 3320 BA Mapwork. Give the map reference of the map west. Hi, Gary from Tehran High School. Do you perhaps know the answer? The map reference of the map west of the Mapwork map. So west will be to the left, and Blackie High says 3320 A, B, absolutely correct. Hans by Academia, very, very active this afternoon, giving the same answer, 3320 A, B. And if we have a look here, the answer is 3320 A, B, because it is this block here. Okay, so it will be 3320, big block A, small block B. Right, well done, guys. Now, when we must give the grid reference the exact position, there are many ways to do it, many ways to skin a cat. And once again, often learners struggle with this. But let's have a look. We must give the position of a point. So we know, what do we know? We know that 1 degree is equal to 60 minutes. 1 degree contains 60 minutes. And remember that the minute here is a unit of distance, not a unit of time. It's a unit of distance, right? Now, that's 46 minutes. The 46 wasn't written there on the map, but on the map it said 26 degrees, 45 minutes for that line. So the next 1 unit down must be 46, and if we go a further one down, it will be 47. Okay, you need to work it out. Similarly, if that is 29.0, This will be 29.01. Each block is 1 minute. So, here we go. Now, we need to give the position of that spot height. We need to give the position of that spot height that's been circled in red, and that has the red arrow pointing towards it. So, we first give the latitudinal position, and that will be 26 degrees and 46 minutes south. And when we go there for the longitudinal position, it is 29 degrees and 0 minutes east. Okay? Now, this is very, very easy because that spot falls directly on an intersection. It's not in, you'll see what I mean now when I say directly on an intersection. So there are no seconds in this case. Now let's give the position of that point there. That trig beacon with a height of 1,590.7 meters. Right. That is the latitudinal position. So I know that it is 26 degrees and 45 minutes. It's not at 46 minutes yet. So my answer is going to be 26 degrees, 45 minutes, and a certain number of seconds. Now, an easy way to work out the seconds, we know also that there are 60 seconds in each minute. So if I divide my block in half, as you can see that little line, that will be 30 seconds. Okay? We obviously can't write all the seconds on the map, otherwise you're going to have your whole map full of lines and you won't be able to see a thing. So that will be the 30 seconds mark. And if I further divide each half into three smaller blocks, then that will be 10 seconds each. And now I can estimate that's about just more than 10 seconds, so it's about 12 seconds, right? 26 degrees, 45 minutes, 12 seconds south. And then similarly, for the longitude, it will be 29 degrees, 0 minutes. You can see it's not at the 1 minute mark yet. And then I'll do the same thing. I divide it in half first for 30. And I can see it is then just over the 40 second because I divided my entire block into 10 smaller blocks. And then it is just over 40 minutes, about 41 minutes probably. Seconds, sorry. 41 or 42 seconds east. Okay. Now, before we go into the direction of river flow, I just want to show you another way of doing it, and I'm going to... Right. Very important. Whenever you are writing down, and at the end of the year, in the matric final exam, this is one of the problems that we pick up. When you are writing down the position of a place, your answer is always going to be something, a number will come in there, degrees, something minutes, something seconds, south. This is how you need to write it. Something degrees, something minutes, something seconds, east. Why? The entire South Africa is south of the equator. There's no place in South Africa that's north of the equator. So you're always going to have an S there. You're always going to have an E there because the entire country is east of the Greenwich Meridian. South Africa doesn't straddle the Greenwich Meridian, so we don't have east and west. Always south, always east. Right. Now, the degrees, these two numbers here, you can get from the title of your map. So I'm just going to draw a very, very simple little map here. And let's say the title, I'm going to make up a title now. The title of this map is 29, 12, AC, whichever town it is, right? So this is 29 degrees, 00 minutes, and 12 degrees, 15 minutes. Right, I'm just going to work in the first block here. Right, and you are asked to calculate the position of that point. Let me just do it in a different color so that you can see it, of that point there. So, I know my answer is going to be something degrees. The degrees you get from the title of the map. 29, 12. 29, 12. It is also, I get it from my first line of latitude. The degree value is 29. My first line of longitude, the degree value is 12. 29, 12. Now, the minutes, you're going to get from the actual block itself the minute value and the minute value. So the minute value here is 0, so it's going to be 0. If it had been here, then my minute value would have been 15, but the minute value of that line is 0, and the minute value of this line here is 15. Now, a different way of calculating the seconds. So I want to get the seconds across here, because that's my seconds line of latitude. So all I do, I measure that distance, and then I measure the entire block, okay? Now I'm just going to make up measurements here. So let's just say that from there to there is, say, 2,2 centimeters, and the entire block is, say, 3,2 centimeters, and it is 60 seconds. So I multiply it by 60. I take my calculator, and I say 2.2 divided by 3.2 times 60, and that gives me 41.25. I can't have a 0.25, so it's 41 seconds. Much more accurate than the other way I showed you, is it not? Now, for the longitude, let me just use a different color once again. For the longitude, I want to get that longitudinal position there. So I do the same thing. I measure from the side to my point. I measure from the side the entire block. And let's say in this case, I'm also just going to make up numbers once again. Let's say I get 2.9. Let's just say over 3.5. I multiply it by 60 because there's 60 seconds. I get at my calculator and I say 2.9 divided by 3.5 times 60. And that gives me 49.7. So I'll round it off to 50. And then this here will be 50 seconds east. Okay, I now I've rushed through it, but ask your teacher, ask your educator, just to show you this method of doing it. So you've seen two ways now, the one on the slide where we estimated the value, and the one that I've done on the sheet of paper where we've actually worked out the value very, very accurately. We have a few minutes left, so let's very quickly, the direction of flow of a river. We know that the river flows towards the sea. In the recent Mapwork assignment my class did, I asked them in which stage is the river, and they were sitting looking at the map, turning it upside down and everything, and if they had any sense, they would have seen that half of the map was taken up by the ocean, and they could then see the stage of the river and the direction in which the river flows, because it ends up in the sea. Then, rivers flow from a high altitude to a low altitude. This river is flowing from left to right or from west to east, from 80 meters down to 40 meters. Then the contour, notice the bend in the contour. The bend in the contour will point upstream. So this river is flowing from east to west, as we see, but do you see that the contour lines are bending towards the east? And then the tributaries join. Look at the confluence. The confluence is the point where the tributary flows into the mainstream. Can you see that the confluence makes a V shape? There, can you see there? That V shape is pointing downstream. So this river is flowing from west to east. Okay? And then if there is a dam wall, you see there's a dam, that line represents the wall. The river's got to be flowing towards your left from east to west. Why? Because the water will accumulate behind the wall of the dam. So as the river is flowing, it gets dammed up behind the dam wall. In which direction does the Steenbras River flow? It's flowing towards the sea. It's flowing from high to low, 300 meters to my right, to the east, 100 meters more to the west. There's the wall of the dam. You see the Steenbras Dam is a large dam. There's the wall of the dam. Here the water is damming up behind the wall. So it is flowing that way. And then the tributaries as well, pointing upstream. Okay. In which direction does this river flow? Southeast. How do I know that? Look at the contour values. 940 in the northwest, 900 towards the east, so it's definitely flowing towards the southeast. Look at the tributaries. Can you see that there? Joining downstream. Contours are bending upstream. Calculations that you need to know. You need to be able to know how to calculate distance. There's the formula. Your distance, whatever you measure on the map, multiplied by the scale, divided by 100,000. Why do we divide it by 100,000? So that we can get an answer in kilometers. There are 100,000 centimeters in a kilometer. This afternoon, take your rulers, go out into the road, measure 100,000 kilometers. 100,000 centimeters, and you should have a kilometer. Right, step one, we measure. We use your ruler, measure the distance. 5.3. Between those 2 points, the distance on the map is 5.3 centimeters. Please write down your units. It's important. You lose marks in the exam when you don't indicate the units. So we measured 5.3. We're multiplying by 50,000. Why? The scale of our topographical map is 1:50,000. But 5.3 times 50,000 is going to give me an answer in centimeters. So I divide by 100,000 so I can get an answer in kilometers. And my answer will be 2.65. What some learners do, they say 50,000 divided by 100,000 is a half, is 0.5. So they multiply immediately by 0.5, which is fine. But as long as you multiply by 0.5, do not divide by 2. You get the same answer, but if you divide by 2, it's going to be marked wrong in your final exam because you are not multiplying by the scale. Very quickly, there's a power line, straight line. Measure 3.3 centimeters, multiply by 50,000 times 100,000, and we get 1.65 kilometers. I don't think I have time left, but what I want you to ask your educators to do also is to show you how to measure along the distance along a curved road. Let me just show you very quickly. I think I have a minute or two. Along a curved road, take a sheet of paper, any scrap paper, make a mark. Put your mark where you're going to start measuring. That's a straight line. Make a mark on my map and on my paper with a pencil, not with a pen. I turn my sheet of paper, I make another mark. I turn my sheet of paper to get another little straight line. I line up my marks and I make another one. And so on until don't use string, don't use the girl in front of your hair, don't use your shoelace. And when you're done, once you've got the entire length that you need, you then just measure. I get 13.1 centimeters, and then I do my calculation, 13.1 times 0.5. I can do it in my head, but I'd rather just do it with a calculator for now. 13.1 multiplied by 0.5, and I get 6.55 kilometers. Okay? So I have measured along a curved distance using a sheet of paper to make little straight line intervals. Until I get to the point that I need to measure. I then use my ruler to measure the entire line, and I can then write my answer in kilometers. Well, learners, we have come to the end of our session for this afternoon. All that I can say to you is that we've barely scratched the surface. There's so much more that you need to do. You need to practice constantly. Sit with your map work every day. Mapwork is easy. It is 75 marks. It is easy. All the answers are in front of you on the map. You are the detective. You just have to go and find the answers. So from me here at the Telematics Studio, I want to thank you for being here this afternoon, for giving up your time. Thank you, teachers, for spending the time with you. I see messages here once again from Blackheath High, Gansbaai Academia, and a school very, very close to me, Bridgetown High. Welcome, Bridgetown High, Mrs. Manuel. And thank you all for coming. Thank you for your time. And I wish you all of the best for your exam now in June and for your final exam at the end of the year. Thank you so much.